If anyone on Zoom has questions, just speak up because I'm not going to look at you. Not as a bad thing, just I can't. So, okay, so let me pull up this file. I'm actually going to send you all something here real quick.
Well, no, I do it.
Go through these.
It's like my 25. Oh no. But I get it. Yeah, like look at that. Crazy.
Okay, so in Discord, if you can download this file I just put in file sharing, we're going to start with an input mesh today. So we're not starting from scratch. We'll have something to start with. And if you pull this up, that should be all you need. So just open that Grasshopper file when you get it. I'm going to show you what we're aiming to get to today by 7. Yeah.
Whoa.
Yeah, no, there's nothing on Grasshopper. It's just the mesh.
That's kind of awesome.
The mesh is like in the Grasshopper file. It's not in Rhino. Just easier to share it this way. Yeah, maybe I should have jump scared you. Well, you know, you got it now, so. Yeah, we're gonna build like an outfit for this base mesh. There, something we could get into this semester is like creating these base models. There is software that you can get where you can like put in certain parameters and get like a human type form for this kind of work. So I think that's where I got that, whatever file I gave you like a bunch of years ago. But it's also good if we think about like what the end product could be. If you're doing like AR filters or something like for Instagram or Snapchat, like could be one use of having this like base character, or game development like a different one. But something we'll get to later. No, wait, did I hit now? Everyone online, sorry about that. It tried to restart my computer, so give me a minute. We'll be back. Okay, we're back.
When was the last time you restarted your computer, RJ?
Well, not a minute ago. So, okay, it's already there.
You've been clicking that later button for a year.
14 is wild. Okay, I'm not going to open the file to show you the thing in Grasshopper. I'll just show you photos from last year when we had the other students do it. But we're going to make a cool little outfit for the human figure. I apologize for all of the updates. For the rest of the semester, we'll be set now, though. So, yeah, I won't have to update anything for the next 9 months. So, we're good.
You could.
Okay. Right.
What if there's this important secret?
Okay, so let's look at the stuff from last year. Where did they put them? Okay, so here's a good example. Yeah. Okay, so we're aiming to make some organic looking thing like this, and we're going to do it with the plugin that finds a best fit line. So it might not be obvious how we get there, but it's not that crazy, and I'll show you today, and then we'll probably post some of these later tonight or tomorrow. Okay, so let me screen share. Realize I wasn't doing that. Cool. Okay, so everyone should be able to see that now on Zoom. Let me know if you can't or you can't hear me or anything. If you have a question, again, just call it out. Okay, so we've got this. Why is my scroll backwards? Okay. Okay, so we've got this person. We're going to take our workflow from last week, so the Voronoi pattern thing, and use that as the base for constructing this line system today. So does anyone remember what the first thing you do when you construct a Voronoi pattern, like what the first thing you need is for a Voronoi? A plane, yes, but we'll call the person like the plane.
Oh, yes, sir.
Yeah, like the surface we're modeling on. What do we points? Cool. So we used the 2D point command last week. This week there's another tool where you can put points on geometry. So okay, so it's called populate geometry. So we can populate points on geometry. Should be pretty cool. So this one's got a couple inputs. The only ones we really care about, though, are the geometry input and then the count, so the number of points. First one, hopefully obvious, is the geometry of the person can go into the geometry input of the populate component. This will put some points on the surface of this form that we have, but we can change the number of points. Again, we could use a slider or a panel. I'm going to pull up a slider from, I don't know, 0 to or 100 to 1,000. Put a lot of points on here. Does everyone remember how to do the slider? Numbers for that? If you don't, just call out or something. I'm going to start around like 400 or so, maybe 300. We'll see, just for everyone's computers, so I don't end up crashing someone else's laptop by mistake, which happened a lot last year, so we're learning. Okay, so with the populate geometry, we have the points, but now we can construct the Voronoi pattern. In this sense, if we do a 2D pattern, I really can't imagine what that would look like, so we'll do a 3D Voronoi. And instead of having 2D curves as the output, it's going to output 3D B-reps of cells around each other. So it'll look similar to what we did last week, but just in a 3D sense. So if we start typing in Voronoi, we have the one we used last week, the little triangle, but right above it, we have this blue like packed little icon. We use that one. This one again has two inputs, just like the one from last week. It's got the points as an input and then the boundary to like crop in the cells. In this case, the boundary is not going to matter too much because we're not actually like constructing a Voronoi as our final output. We just need it as one of the inputs for the rest of the script. So all we really need to worry about is the points. So if we plug the points right in, give it a second, and it should come up with, yeah, this kind of, I don't know, sarcophagus around it of cells. Yeah. Yeah, so if you just grab a slider or a panel, I know right now it says the name of it is count, but do you remember how to pull up a slider? So I did 100 to 1,000. So if I want to do that, I can type in 100 dot dot 1,000, and it'll pull it up. And as soon as you plug it in, it'll change the name of it to count. It's just automatic, but it does sometimes confuse people. So yeah, at this point, we have cells wrapping around the entirety of the object. It's, if you notice, going up right to the boundary of the form that we have. So in some cases, like really close up, we might not get lines looking exactly as we want. And if that's the case, we can start drawing a bigger boundary to make the cells extend out more, just so we like give ourselves enough wiggle room to find the pattern. But in this case, it's not going to matter too much, but just know you can change the boundary if you want. So with this boundary, I'm going to draw a little diagram here. But we have, say, the head of the person, and it's got this like cellular structure on top of it, right? In like a 2D sense. If you imagine like what's happening in here. What we can do is we can find, oh, great. We can find the intersection of the base form with the Voronoi pattern itself. So we could take just the pattern that's on top of the mesh, like this part, and use that as our pattern to start constructing this like form-fitted outfit around it. So I'll move this really well-drawn diagram over here. Cool. So in order to find the intersection between the base form and the cells that we have, there's a lot of tools in this intersection tab. So you can go through and see all these, but the one we're going to use today is the mesh intersection. So it'll find the intersection between two meshes. You could type in mesh, whatever that big line is, another mesh, or you could put MMX as a mesh intersection. It's also in the X tab up top, the intersection tab, and you can find it under physical. 3 different ways to grab it there. But just let me know if anyone has trouble finding this one. A little Han Solo-ish. Okay, so mesh intersection. It's got 2 inputs, mesh A and mesh B. So does anyone know what we need to plug in to the mesh input? Sick. If we look at the output from the Voronoi here, we can see we have all of these closed B-reps. You can see they light up green when I click them. But what does anyone know what a B-rep is not? A mesh. Nice. So we'll need to convert the B-reps to a mesh before we actually input it here as a mesh. Knowing the data types and how they differ can be kind of important because they do tell you that they will require certain things. So like we output B-reps, it wants a mesh. We need to convert. It's pretty simple though. There is a component called mesh B-rep. It's going to be this red one. All it'll do is it'll take our boundary representation piece of geometry, so in this case, one of the cells, and just tessellate it with faces as you would see on like an STL or something when you export it. So that's all it's going to do. It's not going to visually be any different, but it'll just make the data stream a lot cleaner because it does want a mesh, so it'll be nice to give it a mesh. Yeah.
I keep getting some mesh fields.
Mm-hmm.
Which component? I wonder how the person. Okay, if you go back to the start, you see there's that little white icon to your left. Oh, that one. So just plug that one into the mesh component you made. Yeah.
Okay, so at this point, we should have the mesh of all of the cells. I have 150 in my case. But would anyone be able to reason what the second input would be? If we have the cells coming in and we want to find the intersection with the form. Yeah, nice. So we throw this original mesh into B, give it a second, and it should output, if you click on it, just the lines that follow the form of the person.
Mine hasn't done any. Oh, there you go.
Yeah, it might take a second, but we got it now. I'm gonna hide everything that's over top of the person just because it's getting in my way at this point. If anyone doesn't remember how to do that, we can select all the components we don't want to see. And then if we just click anywhere on the canvas, we can hit preview off and it'll get rid of the view of like all of the cells because we're not going to need them anymore at this point. So
What's the bottom right one?
mesh intersection. You can also type in MMX. It should come up. Cool. So at this point, if you zoom out, we should be seeing this like pattern that's locked to the mesh of that person. Okay, so at this point, the shortest walk can start coming in because we have this base pattern is one of the inputs, if you remember from the shortest walk. The other one is going to be the paths that we plan to take. So the start point and the end point is going to be the second input for that shortest walk component. So we have the system of curves here, but if you hover over the X coming out, we'll notice that they're all on separate lists. So each of those, I had 150 cells. Each of those cells, once we do this intersection, each of those cells is going to have its own like party of intersections. And what this one is doing is it's putting them on all separate branches. So one intersection of curves for one of the cells. So you can imagine the outline of that cell is not going to be in its own branch. We don't want this because we just want them all the curves to be together because we're going to reference them together in the shortest walk. So easy fix here, we can just hit flatten on the output and it'll take all those curves that are on their separate lists and just put them into one thing. Because we really don't care about the data structure for this workflow very much.
Mine hasn't done that.
It doesn't have them on like the separate branches type thing, or because it should just look like polyline curve, polyline curve, polyline curve. If it looks like this, if you hover over the X output, then you're good. But if it says something completely different, I'll come take a look at it.
It doesn't say polyline curve, it just gives numbers.
Okay, if you right click on the X and then just scroll down a little bit, you should see a button called flatten. Yeah, just hit that one and then see if it says anything different.
It says polyline curve, but the box is different.
Oh, over top of the person?
Yeah.
Okay, yeah. So all I did was I selected these three components.
Okay.
And then if you right click on the canvas anywhere else, you can see that we have this option for preview off. Okay. So just hit preview off, everything should go away.
Oh, yeah.
Yeah, cool. Okay, so now that we have this flattened list of curves, the best way to set a path is to find a start point and an end point. So if you notice on this pattern, we do have these like kinks in the curve, so like these hard changes in direction. We could just call out all of the points in this intersection of three curves and call that like maybe one of our starting points. We're going to get a lot though because we have a lot of curves, but we can narrow down and just say I want 10 of the points. So that's the first thing we'll do is actually grab all of those vertices that make up the curves. So the way to do that is we can use a component called explode. It'll be this curvy black line, and it'll take our curves that are together, and it'll it'll pick out all of just the straight lines. So we'll have a point, a line, and then a second point. So it'll do that for all of the curves. So we'll end up having probably a lot of points and a lot of curves. Yeah, yeah. Which I'm a little scared, so I'm gonna go down a little bit on the number of points. Feel free to do whatever you want. Maybe we can bump this back up later, but just for speed of the rest of this. Okay, my lowest was 100, whatever. Good enough. Okay, so we'll plug what's coming out just into the curve input. And okay, that wasn't too bad. We'll see all of the points come out, so it'll kind of look inflated a little bit. But if you zoom in, we can see like that each line is now bounded by a single point on each side. So it's just taking those curves and blown them up into segments, basically. So we can see in the output here, we have segments at the top, and then vertices is going to be the second one. We'll end up using both, but just for now, we're going to use the vertices. If we found a shortest walk between every one of these vertices and every other one of these vertices, we would have 10,000 ways to go, which we don't want. We want like maybe 10 or 20 ways to go. So we'll have to find some way to narrow down this list of points into a very smaller subset. So there's a lot of components in Grasshopper that utilize random noise, and we can use one of those to find a random collection of, say, like 10 of these vertices. So the component in this case that'll reduce our points to a random smaller number is going to be random reduce. So it'll be this kind of 4x4 grid. Yeah, how nice. It's named exactly what I was describing. So this one, it's got 3 inputs. The top 2 are the ones that matter the most. The bottom one will be interesting later. It's just a seed value. Again, we kind of went over this last week, what the seed values do if we want to change the pattern. But the most important thing right now is just going to be the list to reduce and then the number of items to remove from that list. First things first, though, if we look at the segments and the vertices, it's broken them back into branches again. So it's no longer curve, curve, curve. It's now set 0, set 1. Which again, we really don't care about the data flow in this workflow. So I'm just going to flatten both of these again, because it's going to work better if they're all on the same list. So with it all flattened, we're using the vertices just for right now. So we'll use the vertices as that original list because we want to reduce the number of vertices. So we can plug that into the list to reduce. So all my vertices come in there. And then we just need to find the number to reduce. So right now, if I have, say, 10,000 points, I'll have to say, maybe I want to remove 9,900 or something like that. We could just use a single slider and say, remove this set number of points. But if we start changing the inputs back here, say I add a lot more lines, we're going to start getting a lot more curves. So our remove 9,000 really doesn't matter as much if we have 100,000 curves. It's basically going to do nothing. So we can set up a little thing of math to just take care of that issue for us. So all we're going to do is a multiplication with like a 0.99. So it'll just take like 99% of the overall thing. So first thing we can do is actually grab that multiplication. So you can just type in a star, which will give you multiply, or you can start typing multiplication, up to you. But for any of the math, you can like just do a plus sign, minus sign, division sign, and you'll get that component. So we've got to multiply. With the multiply, again, maybe we'll save like 99%. You could do a slider or panel, up to you. I'm just going to go like 0.01 to get 2 decimals of freedom, ... up to 1 or 100%. And then move this pretty high. Okay, so the multiply component is going to multiply A by B. So with my 99% or my 0.99, you can plug that into either A or B, should be good. But for the second input, it needs a number here. So if we see the list that's coming out of vertices, what we have coming out is 10,000 vertices. That's not actually the number 10,000, it's just 10,000 vertices. So we actually need that number of how many vertices are in this list to plug into B to do this multiplication by. So in order to find that number, and I use this one a lot if you're ever trying to find the number of items in a list, we can use this component called list length, and this will just find the length of that list. So question?
Yeah. Where is the segment? The B.
The B? Oh, we're getting there. Yeah.
When
That makes sense.
when you're making your list, I keep trying to type in 0.1 and then dot 9.99, but it's giving me 99 instead of.
Yeah, so it doesn't matter how many dots you do in between, it's just seeing that 99 at the end. So you could do 0.99
Okay.
as long as you break it by a number.
Okay.
Yeah. Okay, so for your B question, we have this list length component, which is going to find the actual number of items in the list. So if we plug in the vertices to this, so it took in 10,000 vertices, but what it's going to output is just the number 10,000. So now I know just how many vertices I have and nothing else. So with this single number, we can plug this into B. And then doing that math, so 10,000 times 0.99, I'm left with just shy of the original number I put in. So I put in 10,209, I'm getting out 10,106. So it's going to leave about 100 points or so, which is, we'll see, might be good. We might go even higher, 0.999, but what's that?
We want less points.
So yeah, if we look at this R input, this is the number of items to remove.
Oh, okay.
So if I have 10,100, I want to remove 10,008 to get 2 left. Yeah. So with that multiplied number, going into R, it's now reduced my list quite far. So now we only have a couple points remaining. And again, feel free to preview components off every so often if you don't want to see that old data. Does that make sense to everyone? So we have like a lot less points now.
What did you turn off? The sound to get rid of the.
Yeah, so that's just the explode. It was showing all of the vertices. So since this one's just a single component, you can just right click on the icon or the word of the component and just do preview off right from there instead of highlighting and then clicking somewhere else. Okay, so with the reduce, we have almost everything we need to go to the shortest walk, but I'm just going to grab that shortest walk component because this is the next big thing we'll be aiming towards. So you might already have this on your board, might not. But again, this one's taking a curve group as an input, so this is going to be the whole pattern to find a line within. And then the next input, the wanted path, so that's going to be the path that we define as the start and end to find a path in between those 2 points. So with the first one, so the curve system, we have that coming out of the explode. So let's see. So coming out of the explode, we have all of the segments already. So I have my 10,000 segments. Important thing to do first, though, is let me draw a little diagram again. When we had that 3D Voronoi cell, you know, we had cells like this. Call this 1, 2, 3, right? When we found the intersection, let me just switch a color here. When we found the intersection, we got this intersection. That's going to change everything, whatever. We got this intersection, and we got this third intersection. But now that we've exploded it, we have, again, I have 10,000 segments or so. But let's get a different color again. I've got one line going around this way, one line coming here, one line coming here. But if you notice, we have an intersection of like 2 curves overlapping in these sections where they were up against each other. So Maybe that makes sense, maybe that doesn't. But suffice to say, we have a lot of lines that are right on top of each other in this list. So we don't actually need all 10,000. There's like maybe 5,000 duplicates of just a line over top of another line. So to clean that up quickly, just one component. Everyone should have Kangaroo installed. It comes with Grasshopper. It's probably like at the very end of your list. So there's a component in that one called remove duplicate lines. Just a really nice one to clean things up before we move on, just because using 10,000 segments might bog it down later on. So I'm just going to clean it up as much as possible. So with this component, again, we flatten both of the outputs from the explode, so the segments and the vertices. If you haven't done the segments, do that one as well. But we'll take the segments and we'll go into this first input here. So this is just the list of all the lines that we want to clean up. So we plug that in, that's all we have to do. And you see, I was almost correct. We've narrowed this down to just 5,700 lines out of my original over 10,000. So there was a good 4,000 so that were just the exact same line over top of each other. So in cleaning that up, it should allow us to just have a cleaner workflow here on out. There's one thing that some people might run into, some people might not. It's just going to be like in the random chance of setting up the workflow however you did, is there could be items in here that are infinitely small, which we don't like too much going into this next component. So just so everyone is safe, there is this one component called clean tree. This one, it's going to clean up if you have any null items, so like any items that just are not there, any invalid things or empty parts. It'll just take all of those and remove them, so we get just curves coming out of the end of this. For this one, though, the way we've been working, most of the inputs are usually like the first one up top. This one is going to be that bottom one. So if you hover over the T, we see this is the tree that the data that we actually want to clean is going to be this bottom one. So it might do something, it might not. In my case, I have the same number coming out that I did in. So for me, I can't show how it's helping, but for someone, it might help if you have some weird data going on. Okay, so at this point, it should all be clean and it should all be flat. So we can see line, 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 line. Cool. We can go ahead and plug this as the pattern into this, this top curve group for the short as well. This is the pattern that we're going to walk through to go from point to point. So nothing's going to happen yet. We'll need to fill in this second component, which is the actual point-to-point beginning to destination. With the beginning to destination, though, it is going to be a line from start to end. It's not just going to be point to point. So we're not defining, say, a start point and end point like you would in Google Maps. We'll just draw a line and give the line to the shortest walk to do that solution. Okay, so to get a line, does anyone know how many points make up a line in simplest terms? Yeah, 2. So what we can do here with my list, it's nice because I've gotten down to 102 points. So this is going to divide by 2 pretty nicely. Some other people might have an odd number. It's not going to matter too much, though. We're going to just grab sets of 2 points so we can draw this line from point to point. So the first thing to do to actually just grab groups of 2 points is to do this component called partition list. So you can see the little icon tries to explain it. It's going to take a really large list and it's going to break it up into a lot of smaller sections. So with partition list, it has 2 inputs. The first one is just the list that we want to affect. So that'll just be the data we've been working with. So if we go back a little bit, we have this reduced from earlier, which gives us the vertices. And I want to find pairs of 2 vertices so I can start drawing lines. We can take the output from reduce into the top for the partition, and this will start cutting it up. If we look down at the size of the partitions, though, by default, it's giving us a list of 3 and then a list of 2, which is not what we want because we just want a start and an end point for a line. In this case, though, if you do look, we can see the first branch has 3, second has 2, third has 3. So it's just repeating that pattern over and over, 3, 2, 3, 2. We don't want that, though. We just want number 2 going in. So you can use a slider or a panel. I'm going to use a panel. if you're ever deciding between a slider or a panel, the way I think about it is a slider is going to be something that you can come back later and change. A panel is a lot harder to change though, because you have to double click and like enter new values. So I know I'm never going to change this 2. It just doesn't make sense to change it from the number 2. So I'll just keep it as a panel. So now we can see we have all of these branches. Each of them has a count of 2 items in each one if we hover over C. So now we have the start and the end point that we want to draw a simple line. So we can grab the line component. So it'll be the one that's not in the black hexagon, just the line. With this one, we have 2 inputs. So the start A and the end of the line at B. So at this point, we have a little bit of a disconnect coming from partition and going into line. We have 1 output from partition, but we need 2 inputs for the line. So we need to find that start and the end. We can do that by using a list item. And what the list item will do is it'll take a list and it'll grab a single item out of that list. And we can define which item that is with an index value. So by default, it's at 0. So it's just going to grab the first item in every list. And you can see I have 51 lists, 0 to 50, each with 2 items in it. So if we plug the C coming out of partition into the list for item, we'll start getting the first point in all those lists. And that's just because by default, the index is the first index, which is 0. But we want the first and the second point out of each list. So one thing we can do is if you zoom all the way into item, the closer you get, we'll see these little plus signs start to come up if you zoom pretty far in. If you click the plus button below the I, it'll give us I and then I plus 1. So it'll give us index 0 and then index 0 plus 1, so index 1. So at this point, the first output is going to be the start of our line, and the second output is going to be the end of our line. So we can use that as A and B. So now we get all these lines going around. We're going for something abstract, so we like this bird's nest. One thing you will notice, though, is the wire connection between all these components has started to be dotted. And that's just because we have multiple lists of items. So we have, it looks like, 0, 0, 0, 1, 0, 2, which is different than, point. So it's nice in this sense that we have this graph, because now we can say with only one component, we can construct 51 different lines just because of how the data is flowing. So go back into this later and break it down yourself and try to break it and see like how it fails. Maybe flatten some things, see what happens later, just to maybe get a better understanding of how the grafted list works. But in this sense, it's looking good if we have this crazy bird's nest going around. So that's cool. At this point, though, we do want to give the shortest walk a single set of wanted paths. If we look at the output of the line, we have the branched output, which makes sense because it's how we've been working. But we can go ahead and flatten the output so we get a single list of wanted paths. So with it flattened, it is also good to work if you're going into a certain component and you have multiple inputs. It's usually best to make sure all those inputs are the same. So, both flattened or both grafted. In this case, we have them both flattened, so it should work pretty well. But we can go ahead and plug the lines that we created now into the wanted paths. And we should start to see a pattern showing up kind of like form fitted to this base mesh. And again, just to clean up the workspace, I'm going to preview off some of the older things that are happening here. You might have the shortest walk component telling you there's an error, but if we click on it, we can see it did work. So there's technically not an issue. But there might be some parts where the line that you want to make is either way too short to actually make a path or something else. We could do a lot more cleanup to fix this, but Doesn't really matter for today. We're just getting a pattern, a very abstract organic pattern on the mesh, on the person mesh. So if you don't get like this form fit pattern, let me know. Yes.
Like if you did this, and you're like, I don't really like how the random happens. How would you tell the object is at all?
Yeah, so a couple ways. The first one would be the seed for the points. So we could just say I want a totally different set of points, just like re-roll everything. Or a little more granular, we could come in here to the reduce points and we could say maybe I want a different seed for the number of points I reduced, and then we'd get a different look. You could also just straight up do it by hand, and you could like say you could go in to Rhino and like set a point and then a second point, and then come back to Grasshopper and instance those points if you wanted to do it all by hand. But yeah, with this random, I would probably just change the seed on the reduce just so we keep the Voronoi the same. But yeah, two ways, up to you.
Is there also a way to focus like the points on like the upper part of the body?
Yeah, totally. So one thing you could do is instead of using the whole body as input, we could in multiple different ways just take like a Boolean section of it. So we could like cut off some parts and just say, I just want the right arm to do a pattern on.
Yeah.
That's one way. Or you could come to the Voronoi, and instead of leaving the boundary empty, we could say, I'm just defining a boundary on the right arm.
Okay.
So we still have the same point set that's going to be all over, but it would just like create it on that, say, right arm. Yeah. So a couple ways to do it.
On
Yeah.
when I click on my short walk, it's not showing. I mean, it's orange, but you said it's okay, and it's not showing the pattern. Also, I think that might have something to do with my line output. It's showing like all the way at the end of the list. Like you have line L14, mine is saying invalid line.
Yeah, so that could be an issue that comes up. All you'd have to do is take this clean component, and we're just gonna put it in between the line and the shortest walk. And it should take out that invalid.
Okay. But it's still not like that. The green is not showing up for some reason.
You could also, by default, the clean option, the remove empty is false. One thing you could try is just to set that to true. So we can do that with a Boolean toggle, and then we can set like a true value into that option. That might help. If that doesn't work, you could just redo the Voronoi pattern. So just set a different seed value in the populate geometry, and you would get a different output, which might work better.
Okay, I'll try something.
Yeah.
You go.
Okay, so moving on a little bit more, we have the organic pattern, but it's still like locked to the Voronoi from earlier. It's not that organic yet. It's still very boxy. So one thing we can do is start playing with the curve and converting it into something a lot smoother. Let's see. So the first thing we can do is, let's see what's coming out actually. Okay, so we can use this component called curve to polyline. Curve to polyline. And this is going to make our lives easier in a second. So, oh, actually, we already have polylines. So if this is the case for you, we should just have polylines coming out. So we should be good. Maybe we'll disregard that one for now. Okay, one thing we can do though to actually smooth out the polylines once we have them is there's a component called reduce. This will take our very long curve with a lot of points and just clean it up a little by removing the least significant vertices in that curve. So we can take the output from W, so that's going to be all the curves, into the input of lines to reduce, and we'll get slightly different lines just to start. Next one that we can put in is the smooth polyline, and this will take it, and we can set a different strength here, but it'll smooth out those lines a lot more. So now we can see they've gone from being very angular to being a lot smoother, still wrapping around the form. And depending on how strong the output is, we can turn down the tolerance on the reduce. Right now, it's pretty much at its max at 1, but we can go down to, and this is optional, maybe a number of 0.1, and then we'll see the lines will be a little bit closer to the original, but still pretty smooth. So just depending on how strong you see that result, you could turn down the tolerance on the reduced polyline. Okay, so at this point, we most basically have curves on the form, which is pretty cool. But if we were to pipe them at this point in time, the pipe, as you might know, follows around the middle of this line. So if we add a pipe, it'll go off the form, say a radius of 1 millimeter, whatever, but it'll also go into the form that same exact radius. So if we talk about, wearables in this class, we can't have physical things intersecting with whatever object we're modeling around. We want it to be offset from that. Or it just physically doesn't work unless you believe in some kind of quantum mechanics. But in this case, to actually push these curves off, we can do this other little workflow that by itself is pretty helpful, but it will be a small part of this this bigger workflow. So does anyone know what normals are for meshes?
It's like the like at a certain point that it will normal to the mesh.
Yeah.
Or diagonal or perpendicular.
Yeah, totally. So, if anyone took, high school physics or something, as a bad way to explain it, if you remember like force diagrams and things, like we had gravity and I don't know, whatever force it was going, but we also have the normal, which is going to go straight off perpendicular to the surface is the normal. So you can imagine on like, if we looked really close into a mesh for the most part is going to always be tessellated. So we'll have a lot of tiny triangles. So if we zoom like really far into a triangle, we can see that at its center, it'll have a normal vector coming off of that face. So like straight off of the face, similar to this physics diagram. So we can use that property since we have a mesh input here to move the curves off the mesh based on that normal direction. This is different than just scaling all the curves up, because you could say we could take these curves and just scale them a little bit and they would also get away from the surface. But there's certain ways if we were to just scale them, like they would just kind of go off. But how do we solve the issue of this curve has to go up off the neck and the curve lower down the back has to go down off the back? So we can use the normals as the input vector to do that. So we'll have to play with the curves a little bit more to get that to be the case. What we're going to do is we're going to deconstruct the curves into just their points, and then we can move those points away and then reconstruct the line based on this new set of points that are moved. So the first thing to do in that sense is we can take the discontinuity of the polyline, and just like the explode, it's going to find the points that bound each line segment. So with discontinuity, we've got that curve input up top. So if we plug our curves in, the discontinuity is going to show us these points coming out. So this is a little bit more basic than the explode, but all I need is the points in this sense. So this is good enough. At this point, we'll also need the mesh. We'll need the normals of the mesh. And currently, if we look back all the way at the beginning to that mesh I gave you, all it's telling us is we have a mesh. It's not telling us anything about the mesh, how many vertices there are, how many faces, what the normals are. But one thing we can do, and I'm just going to zoom into the beginning here again, is we can use a deconstruct mesh. And if we plug the mesh into this component, it'll tell us a lot about the mesh. We can see where all the vertices are. We can see where all the faces are. If the mesh had any color, we could see that. But the last one here, we can see all of the normals. So for each, I believe vertice, yeah, for each vertice, there's going to be a corresponding normal. Cool.
It looks like chainmail.
Yeah, pretty much. It's kind of interesting. So I zoomed really far in here, but we're going to need this component at the end of the script. So you can zoom out and pull it back to the end here. The wire is going to start going through everything. So just know that we have a lot of wires overlapping at this point. Okay, so we've got it deconstructed. So we'll be using the vertices and we'll also be using their normals. The way the lists are set up is nice. Vertice 0 is going to also correspond to vertice or to normal 0. So we can use both of them in a little bit here. But first thing to do is we have all of these points from the curve. But if I zoom into this, you can see this one kind of right there. In relation to the actual points of the mesh, it's not on top of one. It's kind of close to, it's kind of hard to see. It's kind of close to this one down here, but it's not on top of any. So we can't just say, I want the normal of this location. We'll have to find the vertice of the mesh first, and then we can take the normal of that location. So it's not going to be a perfect, we move away from the mesh, but it'll be pretty close enough since I am really zoomed in. But in order to find the points that are closest to the discontinuity points, is we can use a component called closest point. I'll just keep typing. So closest point. There's two that are very similar, closest points, plural, and then closest point, singular. We'll just want that singular component because we just want to find one closest point to the original. So we've got two inputs for this one. We've got the points, and I believe we've used this component before, but it might have been weeks ago. We've got the first one, which is the point to start the search, and then the cloud of points to search within. So we have the points that we know we want to move away. So this will be our start. And we want to find the closest point to one of these and use that point's normal value. So we can start here by using the points from the discontinuity into the first input, so the points to start the search. And then we can use the vertices as that cloud to search within. So in this sense, I'll explain it really quick with the component, but don't do this part. So we can see what's happening here if we put in that original point and then the closest point that it found. We can see now this same point right here is finding its closest friend neighbor, which is right over here. So this point has a normal, and we can steal that normal and use it for the point that we actually want to move. So we don't need this line. So in order to do that, if you remember what the list item was doing, it was finding a singular item within a list based on an index. So this I here. We can use that exact same concept to pull out the normal that corresponds to the vertice that we found. So we can see we have a couple outputs. We have a point, which is the closest point to the original point we searched from, which we're not going to worry about. But we also have the index of that closest point. So we can use this index as a search query to actually find the normal that we need. Visually, we're not going to see anything when we do this, but we will see how it affects it later on. So with another list item, we can use the L as the list that we want to find items within. So we'll call that the normals. We want to find a normal. And we can use the I, so we found the index of that closest point, So we can use the index of the closest point to find also the normal of the closest point. So we used a lot of, points to find close point friends, but we actually really wanted the normal at the end. So we can plug the normals into the list because that's the thing we want to find. And then this index coming out into I, we should now have a list of just a bunch of normals, which isn't normal vectors, I should say, which isn't anything visual right now. So now that we have all of the normals and we have all of the points that we want to move away from the mesh, we can do that move. So we can use a component just called move. It'll take a point and it'll take a vector and it'll move a point in that distance and direction. So with move, we've got both of those inputs. We've got G as the geometry to move. So we know we want to move the points that made up those lines. So from the discontinuity, we can use those points. And by default, we have a Z vector of 10. So we can see it just moved all my points straight up into the air by default. But since we actually have the vectors from the original mesh, we can use those to move each point in its own unique direction. So we could just plug the normal vectors in to the translation vector to move them, but we have no control of how far away they're going to be. They're just going to go an arbitrary amount away. But we can actually define that distance. And working with vectors, there is a vector tab where all the vector stuff sits. But the one that we can use is called amplitude, and amplitude is going to set that size of a vector. The vector doesn't really have a size and more just has a direction and a set distance to go in that direction. So the amplitude is going to set that distance. So we've got a couple inputs for amplitude. First one being the vector. So we can use the vectors coming out of the deconstruct mesh and then the list item. So we can take the vectors from the list item into the vector input. And then we'll also have to define a size. By default, it's a size of 1, but we can use a slider to make this range variable. So I'm going to do 0.01 to 1. You can set whatever size you want, but I think in this scale, a number of like 0.2 is going to work best with the input mesh that I gave everyone. So I'm going to put in a value of 0.2. You can do whatever. But now we have that vector, so we have that direction to move, and we say we want to move 0.2 units in that direction. So now things will start changing. Once I plug this vector into the translation input, all those points are going to go off of the mesh. And I'll zoom in and do this slider, but we can see the points coming farther and closer away from the mesh in relation to the direction of the mesh at that point. So we've just combined like a lot of things together to get this to work. But as I said, this little section right here that we just put together, you can use this in a lot of different ways. So I'm going to group this, but you don't have to do this. You could have some sort of building and you could like do a exploded view and move everything away from it. You could do different kinds of patterns on surfaces and such. Whenever you have points and you want to move them off of a mesh, that's all we need for this little section to work. So this is kind of like a sub workflow within today's larger thing.
Really, I can say this. How do I turn this back?
So if you right click on the word and then just hit enable, it'll come back. Yeah. So
How do you?
Yeah, Mohammed.
How do you name a group again?
Yeah, so yeah, I just did a group, which if you were watching me, you can come over and then hit group. If you want to name it, you can just right click on the group itself. I think it's not going to be white for everyone. It'll be a purple color, I think. But if you just right click on like any of that purple, we can just type a title in here and it'll automatically show up on top.
And you said this this does the what again?
Yeah, everything. You mean like everything in this group, what it does?
Yeah.
Yeah, so everything in this group, all it needs is a mesh and a list of points, and we can move with just this small group points away from the mesh in relation to the mesh's normals. So it's like a more optimized scaling method that isn't just a very generic scale. So this is going to work really well for our pipe because we can set whatever this amplitude is also to be the radius of that pipe. So we know if we move 1 inch away and we have a radius of the pipe of 1 inch, then it'll be right on top of the surface of whatever input mesh that we have. Yeah.
When you move the amplitude slider, still it's only like all the points are just going straight up and down. Not like expanding on.
Okay. Yeah, so. Yours is a little different. So instead of using the normal as the closer point, you actually use the point. So if you just wire the vertex into that seed, it should fix it. Yeah, question.
Yeah, there we go.
Good. Okay, let's see. So if you click on that very last, just click on that move up top. Yeah, that's what we can see. Yeah, just click on that. And then if you move the slider, what happens? So yeah, just move that dot.
Oh, this work?
Yeah. Cool.
How did you make the?
Rematch. How did I make a rematch? Okay, we good? Yes.
How do you make the group for that? Like, does it matter putting it in the white box?
It doesn't. Just to say that you could take this piece into any other workflow,
Oh, I see.
and all you need is points in a mesh to
Yeah.
do this same thing, but it could be on any mesh. But in order to make the group, you just select everything you want in a group, and then you can right click somewhere else,
Okay.
and then just hit that group button. Yep.
Then you can just make a title for it.
Yep. You can just right click on the purple, or just single right click on the purple. It should just be one little box that comes up. So click with the finger. Yeah, there you go. Yep.
Good.
Cool. So at this section, we have the points moved away, but we can't pipe points. We can only put a pipe around curves. So to start this, first thing we'll do is we'll make use of that cleaning component again. It's a very nice component to have. And the reason we're doing that is because if you hover over the output of G, we see I have stuff in my first group and my fourth group, but I have nothing in between. There's just a lot of sets with nothing in it. So we'll grab that clean tree again. Wire it up just like last time. And we'll have to toggle on the remove empty because I have a lot of empty branches, as you can see by all the zeros here. So we'll have to toggle on empty branches. The way I did it for Muhammad earlier was to use the, and this is kind of in the way for everyone, is to use this Boolean toggle. It's kind of just like a button you can hit to change states. Does anyone know what a Boolean is generically? Yeah, true or false, 0 or 1 binary type thing. So that's all this really does. It's a set state though, so once you click it, it'll be set to true or set to false, which is different than just the button, which is like an instant of true, and then it's usually always false. This one will stay in its state. So if we set this to true, we can set the remove empty to yes, please remove empties. And then on the output here, we should see no sets with 0 in them. We only have sets with stuff in them at this point.
Is it Boolean toggle?
Yeah, or you can just type in toggle. Another thing, since we have time and for anyone that wants to work with like less components, we could also just right click on the E and set the Boolean state in a menu if you want. But then it might get a little confusing on the screen, like if it's actually set to something or not. So just showing you there is other ways to do this. So now that we have all of the invalid empty things gone, we can actually reconstruct our line. So It's important also that we still have these different branches because we want to redraw the same lines that we deconstructed into points earlier. And we kept it in all of these branches because, you know, the first curve had 16 points in it. So we want to build a new curve with those 16. If we were to flatten this, we would just have like 300 points of a line going everywhere. So keeping it in these little, these folders is nice because we'll reconstruct the curve here and it'll look pretty good. So we can use a component now called interpolate. So at the top of my screen, that little black line with some dots in it, curvy around, interpolate. So this is a nice way to make it's like making a smooth curve. A polyline is a lot of segments that make up a line. This one is mathematically a very smooth curve. So I can pull this one in. We can take the vertices that are coming out of the clean tree into the vertice input for the interpolate. And I'm just going to turn off a lot of things again, preview off. Still something on.
Mine is red.
Your interpolate curve. Did you use the clean and put the true value there?
No. Wait.
Cool.
Now.
Awesome. Yeah. So if we didn't have this clean in place, it would try to start drawing a line between 0 points and it would fail. So now that we've removed all of those null points, we have smooth curves again. And you can see the curves now. If you zoom in, it doesn't matter how far you zoom in, you're never going to find a line segment. It's very, very smooth, which is nice. But keep in mind, it also loses some definition from earlier. If you really wanted those lines to follow that exact path from earlier, then this might go over the bounds. But in this sense, we just want it like very smooth and organic looking. So interpolate's a nice way to flip to that. Okay, so at this point, if you remember the images from the beginning of class when I showed you, they were very symmetrical. The left side looked a lot like what the right side looked like. Let's find a good one. So basically what we've done currently is we have one of those halves. Say we have the right half of the curves. And I don't want to do all of this again to get the other half. So something that we can make use of in the plugins that we installed is within Pufferfish, there's a component called mirror cut curve. What this will do is it'll take curves, it'll cut it down a plane, and then it'll mirror the curves from one side to the other. So we can just invent symmetry over a random mess of curves. So with mirror cut curve, should look like this one. There's a lot of other mirror cut components. Pufferfish it's probably one of the plugins with the most components out there. You could mirror cut meshes, VREPs, whatever, but we'll do curves here. So let me know if you can't find it. But for this one, there's two important inputs. There's the curves and then the mirror plane. First thing for the curves, if you notice, my set again is all grafted because we have the points on all these different layers. If we were to do the mirror cut, it would mirror cut like every single curve separately, which is kind of weird. Not exactly what we want. So we can flatten the curves coming out. So now we have one just set of curves and we're just going to mirror all of them at once instead of doing like each layer by itself. So we can plug those curves in to see, but we'll still need the mirror plane because it doesn't have a plane by default. Could anyone tell me what the plane is that runs, what is it in medical terms, like laterally through the person? I don't know, like from front to back. Yeah. Oh, medially? Does anyone know what plane is running medially? Does anyone know how to figure it out?
YZ.
Yeah, YZ. So if everyone looks down at the bottom left here, we have these little axes. And we can see as we move the Rhino view, they also move with us. So if we see we want to go medially down the person, we can choose this YZ plane that'll go straight through. So in order to grab that, if ever you want the basic, there's 3 basic planes, XY, YZ, and XZ. We can just type in those 2 letters. So if you type in YZ, we'll get a YZ plane. And you should see it populating in Rhino. There's going to be a plane that cuts this model straight in half. But it'll be down at that center point on the grid. So with that plane, we can add that to MP. So that's going to be the mirror plane. And it'll magically take our curves and give them a sense of symmetry, a sense of something that we actually planned for this to happen sort of look. There's one thing to note.
This looks like shorts.
Nice. There's one thing to note about this. If we look back at the original interpolate curve, on mine at least, I have a lot more stuff going on the right, well, our like stage right of this person. And when we go to the mirror cut, it's mirroring what was on the left side. So maybe that's the look you want, maybe it's not. There is, as you can see, a lot more options here. We could flip this direction and say just grab the other side. So again, we can see by default it has false, which we can infer is going to be a Boolean value. So we could use another toggle going into the capital F input, and we could flip this toggle and get a different side of the mirror cut. So now we kind of like two totally different patterns just based on which side we're mirroring. So I'm going to take the right side just because there was more stuff going on in my case.
Oh.
Did you reconstruct the curve with the interpolate? So we moved all the points with the move command from earlier with those normal vectors. And then with these two, I reconstructed a curve from those points. Look them.
I have the point, but I have the line for myself.
There's a lot of stuff.
It's only like 90% in it. As long as the same thing. Like, oh, yeah. It's just, it's like, I don't know.
If you do
Doesn't be the line. Yeah. Crazy story. Oh, yeah. So, you know, you have inspired me to get. Yeah, like, I need to see spice it up, but like getting there this much is really. I never.
Okay. So now that we have these curves, we can do the pipe commands now. I remember last week we used the mesh. Oh yeah, so there's this little pen up here. Yeah, you can draw stuff on the canvas. Last week we did the mesh pipe to make a pipe out of mesh. But today we're going to make a pipe slightly differently. I like this method a lot better. Okay, so everyone should have downloaded the plugin Dendro, which is going to be the uppercase D to the right of your plugins up top. It's only got a couple components here. But off chance, does anyone know what voxels are in like 3D work?
They like,
Yeah.
they're little subdivisions of it.
Basically, I refer to it like as a 3D pixel. So if you imagine your screen has like a bunch of pixels, a voxel is just the 3D sense of that. So we can take any space and fill it with a bunch of tiny little cubes for the most part. But the nice thing about that is once we do that, we can start making a workflow where instead of making a mesh pipe and then trying to Boolean union that mesh pipe together and it kind of looks meshy and weird, we can do it in a voxel mesh method, which is going to be much, much smoother and much better for 3D printing, more importantly. So that's what all of these, only a few tools will help us do. So the first thing when you go to voxels, and just like this workflow from earlier, moving the points, the next part we do, you can use this for pretty much anything. If you have curves, we can make a really nice 3D printable object just with curves. Okay, so up at the top here in this Dendro plugin, only a few important things. The first one though, convert. What this can do is take any kind of geometry and convert it into the voxel space. We're going to go into the voxel space for a second, do some work in there, and then export back out into a mesh that we can actually like work with physically. So we kind of have to go into this one space and then export out of it. So it'll kind of be self-contained in what we're doing next. First thing though, since we have curves, we can turn the curves into a volume. This one, it takes curves, a radius value, and then settings. So the first two are generic pipe stuff. So you need a curve and you need a radius. For this one though, the volume curve also needs some settings. So this is basically saying, if you can imagine, we're in a space, say, and if we voxelize it, we add a lot of like squares into this to fill this space. So could be like this. And then these boxes are going to be our new representation of volume. So the smaller our setting value is, the smaller these boxes are, the more well-defined that overall shape is. The higher the value is, say we had, like, say all these are like 0.2 or something, and then we come in with a setting of like 1, and now we have a voxel of 1. Now we just have a cube, which is very far removed from the original shape that we were trying to get. So we'll keep the samples of the voxel a lot smaller. But we'll see how that goes in a second. So for that settings input, we will need to create some settings. So we have this volume setting component that we can use to define the level of detail that we get with this workflow. So with this settings component, the only really important thing is going to be voxel size, which is this first input here. By default, it's 1. But usually I work from, say, 0.01 to 1 to give us some range to figure out where the best voxel size is going to be. So I'm going to do 0.01 to 1. I recommend you get a similar slider so we're on the same page. But before we do any work with the volume, I'm going to put this slider all the way to 1. So as high as the slider can go. It'll be important so we don't crash anyone's computer doing this. Again, the smaller the voxels are, the more we're going to have to fill the same amount of space. So if we start at 0.1, we're going to be like as detailed as possible, which could be really, really heavy. So if we start at 1, yeah, it's not going to look good, but at least we know we're not starting with crashing our computers. We'll get to that point. So Yeah, good time to save too. I should I already have the save somewhere else. So okay. Turn that up to 1, so we have the voxel settings. We can now plug the settings into the S for the curve. So we'll start with just setting up the settings. After that, we'll put in a radius value. When we work in this way, it's important that the radius is like 33% larger than the voxel, just so we can like see something. If it gets smaller, it'll start yelling at us, being like, I can't compute that if it's smaller, because the boxes can only get so small if the radius is like smaller than the boxes. You see, it doesn't track. So we'll get another slider. I'll just start at the same low value, but I'll go up to like 10 or something. So we have at least space higher than 1, because we need to be at least 33% over with the radius.
What did you do?
I just did like 0.1 to 10. Yeah, I just want some larger values. Okay, so we got the settings, we got the radius. Now we can actually plug in the curves and something should show up. But make sure that number for voxel size is at 1 before you plug the curves in, just to be safe. Okay, so it'll probably be a little bubbly just because the radius is like super big. We can come in now and start refining the size. So if we pull down the radius, we can see the curve will be a little bit more defined. But in this sense, with the voxel size at 1, that's also a big size. So basically at this point for the next minute or so, I'm just going to start moving these sliders until I find something that looks good to me. It might be different for other people, but since we're working with the same like scale of the body, it'll be pretty close.
I agree with not getting.
Yeah, I'm getting something wrong with my.
Is it red?
I never do it too, but
Yeah.
Okay,
Okay, let me give you this thing, because sometimes it does this. So basically, the better way to work is to take the curve, divide it into a bunch of tiny points that are like really close next to each other, make those a volume, and then like it'll look like a curve again. I don't want to like build that with everyone, so I'll give you this and we can plug this in and it should work just fine.
I will say my bubbles.
Yours work.
They work, but they get exponentially huge. And I had the slider, like, it's 129 and it's very small, and then I put 160 and it's huge. Like that way that as the more I slide, it's not the same.
Yeah, we'll need to refine those sliders in a second. I'm going to give you this just to speed things up. So we'll use this curve from point. So open up this Grasshopper and just copy this group and paste it right where we're working in the script. Okay. Is everyone able to get that in?
You can just control, yeah.
Yeah, Control C, open up the other Grasshopper window. It's not copying or it's not working?
I just did it.
Oh, yeah. Good to learn. If you just copy paste, it'll go exactly where it was on the old document. Another way to work, if you remember this, is we can do Control Shift V and it'll paste on your cursor. So
Oh no, there's too many.
nice about this though, you can just grab the white box and everything.
Oh, you're right, because of the group.
But deleting it will just delete the group. So maybe move it away, select everything, and then delete.
Okay.
Yeah. Okay, so if it wasn't somewhat obvious by the group, we'll plug the curves into the big thing labeled input curve, and then it should work. You could also move the pipe radius slider a little bit to make it. Oh yeah. Also, thank you. Yeah. And now we can hone in on this pipe radius value, and we'll get the curves actually being solid. This one's doing a little bit of math to do that 33% larger calculation for us, and then also converting it to points. For some reason, I've talked to the person that made this plugin too, and they also didn't know why the curve works. Sometimes it doesn't work other times, but the converting it to points is always safe. So just know. That
I might have.
it might, yeah, I think that's an unblocked issue
Oh,
on the plugin. Yeah.
Should I just read down and then from the zip file and then unblock it as a zip file?
Yeah, you could try that, and it should work after that.
You think mine's doing the same thing? No, wow, there's.
Hover over the little bubble, a little red bubble. Yeah.
Do you mind just like giving it
Yeah.
out? Like, fix stuff
Yeah, it's
that
okay.
I did stuff.
Let me just make this a lot bigger. Is that good?
Thank you.
It could be an unblocked thing, or it could just be a Mac thing.
Okay.
I have no way of
So
knowing.
is that. Well, what is DLL? Where did that happen?
It should. It should also be in the zip file. And it should go in the components folder with the green one. Yeah.
I think
Oh, yeah, I think there's multiple in the Dendro, which I actually don't know what it looks like. I don't have it downloaded like here.
Because I think that's what it was asking for, like, yellow.
Okay. Yeah, I'll see if I can find it quick here. But yeah, check it again. Let's, yeah. But it could just also be an unblocked thing, and that's like a generic error. Not exactly sure. Okay, so for everyone at this point, we've got 3 minutes left, which is perfect because I have 3 minutes left of talking I want it to do. Lines up pretty well. Okay, so last part for this, if you zoom out. What's the bubble?
Do you have bubbles on your guy? Okay.
It wasn't working.
Go back to the
Those
file.
components were showing up and then I finally got
Yeah, does it need to be that deep?
We'll meet after class.
Okay,
In 2 minutes.
okay.
Yeah. Okay, so if everyone zooms out, I left this little piece over here. This is the fun color piece. But one thing to do before we add fun colors is we're still in this volume space. We need to go back to a mesh so we can add the fun colors. It's only 2 things though. Back under convert, we have a volume to mesh. So we go out of the volume to a mesh, which is nice. But you see it also needs the settings input. This one, it doesn't matter what settings it has. You could do the same ones from before, or I usually just create a new settings block with no inputs and wire that in, and it's fine. And then we can just hook up the volume to volume, and we get a mesh coming out. So with that mesh coming out, I have this mesh join component just sitting there in the big group. It was kind of like down here. But if you grab that, and then we plug in our mesh to that mesh join thing right here. All this is doing is like if there's multiple meshes, it'll just make it one thing so the color is nice and easy. Once you plug that in, we can, let's see. If you highlight over everything and just enable everything that's in this group, It should add the fun color to it. You might have to preview off everything before, but now we have fun colors. So with this one, if you remember the attractor point thing we did last week, where we had a point, we found the distance to all the other points, and we use that to like affect something. I'm doing the same thing here. We can see there's a point at the bottom. We're finding a distance between all the other points, and then just applying a gradient based on how far away they are.
One time, sorry.
Yeah, so did you get to this step and bring it back to a mesh? Yeah, so all you have to do is plug, oh, you have that. So, okay, if you zoom out a little bit, just select everything that's in this white group. And then off to the side, we can right click and just hit enable. Yeah. Yeah, it's fun. And you can also come into this gradient if you want, and we could do, there's a bunch of presets here. We could do a different preset color. Little pink one, little black and white thing, kind of nice. Little rainbow, kind of vibing. And then you can move around any of these dots as well, and it'll affect how the color goes on that gradient.
Now, why does yours look flat?
Yeah, so it takes away any of the like ambient occlusion from. Does yours not look flat? What? If you look at that. Let me try that. I'm in shaded view. Wait, I am. What? You okay? Maybe I should actually update software and get an updated version of Rhino. Because it could be that. Could be that. Like the flat? Yeah. I mean, this one looks really.
Enable the.
Yeah. So, well, I'm wondering. Well, if I have that turned on, it does. Well, I mean, kind of. It's basically just previewing like the red underneath.
Oh, mine is still.
Which I mean, I could change it. Like I could make it a black base, and it might make it pop more, or go all the way white. I guess.
Are we turning this in?
Mohammed, yeah, if you just take a screenshot, we'll put him in the Discord later, but I'll mention that.
Yeah. I was just asking because I have to go really quick.
Oh yeah, no worries, no worries. Yeah, you're good to go.
All right, thank you.
Yeah, if you click this little orange and white sphere, we can affect like the normal setting and then the selected setting for different components. That's why the person also turned white at the same time. Cool. So that's all I have for the workflow. If you're able to get to this point, please, if you can take a screenshot and just put it in the Discord, we'll like get another list of your random outfits again this semester. Let's see.
Do I need to put it right now?
You can do whatever. But yeah, that's all we had. If you have any questions, feel free. Next week.
I have a question, but it's about last class.
Yeah.
Open up the file. I have a question. I have the other one, or brown one. Yeah.
Yeah, I don't know what's going on with that. I don't know.
So. I was gonna say, so I just didn't have it here, and I don't have like the review cut.
Oh, so short of talk and fish.
Yeah, and I don't know why.
Other fish is over in that
In
corner.
Kansas.
Yeah,
it's
kangaroo
not-
comes standard
Oh.
with grasshopper, but if you put on pufferfish. Yeah, so it's probably just a block issue because there should be a lot more coming in.
So, I don't know what I do.
So if you right click on short of talk properties. Yeah, then hit apply, and then okay. And then it will probably be the same thing for pufferfish there too. Which, yeah, block that one.
Oh, wait.
Yeah.
Oh,
Sorry.
okay.
And then so for the sub-D components are technically there. But okay, if you restart, you should get all the pufferfish and
Okay, what do I need to have saved?
everything here. There's nothing in Rhino today, just grasshoppers. It's a big grasshopper.
Okay. Hi, so what having this problem here? Yeah, this
So, yeah.
This one is fine, but this
Okay.
one is not.
Yeah, so we just gotta flatten something somewhere. If you go to the right a little bit more and the canvas, do the canvas. Okay, so. Right up here, we flatten that.
Does your?
So we might just see one circle and the other circle. Yeah. Oh.
Oh, mine's not, mine doesn't even show up, huh?
I'm running that.
Oh.
Okay, so this keeps popping up. I did it before and I just closed it and it was fine, it was good. Okay, so just close, it won't have to, okay.
Yeah.
These platforms are good. Oh,
Yeah.
I just.
So,
If the first, if it doesn't work, we'll take it. So if you. I'd recommend go back to where you put the plugin in, so like file special folders. Just remove it, like, yeah, just delete it. Just go from start. Yeah, the next week.
Yeah, it's like they're.
Open in right now. Okay, we can just add it in before we close and restart. So we don't have to close and restart twice. So if you go back to the file special folder, that would,
Oh, wait.
okay, and then go to, and grab another file explorer window, just so we can see your downloads at the same time. And the one I gave you, yeah, like that plastic, so change plugin one, right click on that. Go to properties, hit unblock, apply, okay. Unzip that. Yeah, just replace it if that's not. Cool, so open that. And then we should open bufferfish. Okay, so take that bufferfish, put that into the components folder.
And that was.
And just like a single one. Yeah, right there. Try to replace it, it might yell at you out. Okay, hit cancel. If you just rename it before copying. It should like. So go back to the folder that we're just in that you copied it from. No. Yeah, yeah, so just change that name. Well, now it's closed, so we don't have that issue. So now, now that it's open, this up real quick. Oh, we still have this open, good. Try to delete it now. Okay, now copy the other one. Perfect, and then go back to the file right. Okay, so those are different, so we can't put them in now just because I need Grasshopper to find this folder, but these will go into a different folder in Grasshopper. So restart Rhino and open it up. Question?
Oh,
Yeah.
it doesn't work.
Yeah,
It was
well, I feel like maybe, I don't know if you have the same issue, I just wanna figure out if I installed it right, or right.
Oh, for Dendro?
If it's, I wanna know if it's just like a Mac thing.
Yes, sure.
Yeah.
I think sweater is more. I think your sweater.
What?
Did you put on this?
Oh. Yeah, yeah, I'll pull it up in a second. Wait, did you ask if I could actually like make that? Someone sent me a DM and I never responded. Okay. I think as of the most recent update, it still doesn't.
No, that is so.
Yeah, it's that
sad.
same error.
Hell.
So yeah, you need
Needed,
boot camp or
but I
something.
can't run boot camp. This is the M1, it's like a newer version of it. It doesn't, it doesn't, I like can't do it.
That's great. Wow, Apple loves it.